So in this video, I'm going to discuss the shortest string that contains 3 string problem which occurred in today's LEETCODE challenge. So if you have any doubt regarding this, you can ping me up on Instagram. Even you can join my Discord server. I will provide both the links in the comment section. I'll pin them. So the problem statement is very simple. You're given 3 strings and you have to find the lexicographically smallest string which contains all the 3 strings. Okay, for which every string A, B and C is a substring. Okay, so this is what the basic logic of the code tells us. Now there were 2 given custom cases. This is a very important case. I have added this case because if you don't get this case, then like you will get difficulty in the I think I don't remember, but there may be some difficulties. Okay, if you don't get this step. So for this, what you can do, so let's say this is A and this is B and this is C as it has been given. So how can we concatenate all the 3 strings? We can make it ABC, that is in factorial 3 ways, right? So that is ABC, ACB, BAC, BCA, CAB and CBA, right? So what is ABC? ABC is nothing, but if we concatenate, that is union of A comma union of B comma C, right? And this is also union of A comma C comma B, right? This is the union of whole thing, so this is how we have to find the 6 strings. Okay, the 6 strings separately. Find the 6 strings separately. This is the number 1 logic of the code. And then when we get all the 6 strings, then we have to return the lexicographically smallest among them. So what we have to first do, first of all, we have to find the smallest, and all the smallest that we find, we have to print the lexicographically smallest one. Okay, so for this union thing, now the most important thing, the union thing. Okay, so let's say this is the most so let's say we have 2 strings, union of X and Y. Okay, so what we can do is, so let's say the length of X is N1 and the length of Y is N2. Okay, so you have to find, that is in a let's say X is, let me take an example basically. So let's say X is D A B C and Y is B C A. So it is very much evident from this that we can merge this BC and BC and make it DABCA, right? So this is what union of X comma Y would look like. Now how we are going to do that? So let's start by, let's say, pointer 1 and pointer 2. So pointer 1 points over here and pointer 2 points over here. So what we have to do is, so see from this position, what is the length of the remaining array? It is 1, right? Because from this position we can go to only one place. So from this position also go to one place, that is B. So C, if C and B is equal, no, it's not equal. Now what we do, pointer 1 minus minus and pointer 2 plus plus. So now pointer 1 points over here and pointer 2 points over here. Now what we are going to check, if BC is equal to BC. Okay, now let's say, now since it is equal, so what we can do, we can concatenate this string and the remaining part of the string, that is from this part. Okay, from this part. So let me take another example. So let's say it was DABC and ABC, right? So pointer 1 pointing over here and this is over here. So is C is equal to A? Nope. Now this pointer points over here and this pointer points over here. So is BC equal to AB? Nope. Now this pointer points over here and this pointer points over here. Is ABC equal to ABC? Yes. Now remember one thing, we don't stop checking after we get it. Okay, we don't stop checking after we get it. We have to go on checking till the end, because you know what, that let's say this was I can't think of an example, but you have to go on checking. Okay, you have to go on checking, like if there were like D, E, F and F, E, so you have to go on checking like D and this D and check if it is possible or not, because there may be a case like A, B, C, D ABC, and over here also ABCD, ABC, right? So if we stop checking, so see for CC, this is C is not equal to A. For this that is BC is not equal to AB, and when we go to this, ABC is equal to ABC, right? But if we go on a larger scale, so the DABC is also equal to this, sorry, DABC, not DABC. So this whole thing ABC DABC is equal to ABC DABC, right? So we could have used the whole string, but we are using just a 3. So what we have to do, you have to do this until pointer 1 is greater than equal to 0 and pointer 2 is lesser than what was the length of, it was n2, right? So lesser than n2 minus 1. Okay, so this is how you are going to find the union. Now there is an exceptional case, that is this case, as I have mentioned. So see, for this case, what we are going to do, ABC and B, the union of ABC and B, right? What is the union of ABC and B over here? It should be ABCB, right? But it is ABC because B is already contained in the string. So what is a special case for this union thing? So before checking anything, before checking this portion, you have to find if A contains B, then return A, or if B contains A, return B. Okay, so if A contains B, return A. If B contains A, return B. If neither of the conditions satisfies, then we are going to use this method. Okay, then we are going to use this method, and once we are done with it, we have to return the smallest string. So you know what, like for this, it is basically A, B, C. So see, for this ABC gives us A, B, C, A. Okay, and for this CAB gives us A, and union of A and ABC is like A is common in both, so BC, and then BC for this and this, BC is common in both, so we are going to append A to it. So there are many, I'm just taking 2. So see, for both of them the length is 6, right? But which is lexicographically smaller? This. So we are going to print this. For this, same thing, ABA. So this is basically C. This is basically ACB. Okay, because if we concatenate AB and this and this are common. So for this we are going to append the remaining portion, that is ABA, and once we are done with it, we are going to concatenate this to this, that is BA is common and BA is common, that is we are going to concatenate the remaining portion, which is nothing, so ABA, right? AB. For this ABC and B, I have told you that it is going to be ABC because of that special case thing, and then ABC and C, it also contains, right? So see one thing over here, for this case, for this special case, if we do it, so we don't even have to calculate the remaining thing, that is n1 and 2, we don't even have to do that for this, right? So this contains both of them, so this is going to be the answer final. Okay, so this is the basic logic of the code. So let me repeat it very much, like in a brief. You are going to take 6 strings A, B, C, C, A, C, B, all this, and you have to find the union of them. The union function is nothing, but first you have to check the special case, that is if A contains B, return A. If B contains A, then return B, and if none of them satisfies, then you have to like do this approach, like go towards the left of, from the right to left of X and from left to right of Y, and check if the substring of that length is equal or not. If it is equal, so you can like remove that portion easily, but you don't need to like stop checking once you get it, to get both of them equal. You have to go on checking, because in this special case also, like, so for this checking you have to do this checking until pointer 1 is greater than equal to 0 and pointer 2 is lesser than n2 minus 1, that is throughout the whole string. And once you are done with it, so you can return like whatever the remaining portion is, right? That is whatever pointer 2 is pointing at. Pointer 2 is going to point at, like for this case, pointer 2 is going to point at now A, right? So you have to return A plus, I mean concatenated, remember one thing, A concatenated by B dot substring of pointer 2. Okay, like you get it, right? So that's the basic logic behind this code. That's it. Thank you.